question about the post-gate
then
design.
maybe so it's better to stop the shorter than I expected. But this is actually thank you, Miyoshi-san, for my introduction. And so actually this is this work is done with my colleague, Ms. Tatiana. And so this work is a part of the Miyoshi-san's CREST project. So my background is actually the system software researcher, including operating system, communication, and file I/O. And so I'm not familiar with, unfortunately, the data simulation nor the simulation for the weather prediction. And our understanding is the model simulator and the simulation, those two components have been designed and developed by the different research groups. And so they use their own the application, they're written in MPI, and also uses some file I/O library to read and write the data. And our mission is to couple such kind of the applications, so independently developed. And they need actually to couple those applications, they use the file I/O, but it consumes the time. And it's okay if they do not need the time critical the application, but the Miyoshi's CREST, so he already gave you, but this one cycle should be done within 30 seconds, and so that means the one of the atomic critical part is actually the file I/O. So we have to remove the disk access for file I/O, and so and also the observable data set will be delivered to the supercomputer via internet. So we have to also reduce the delay latency of the such kind of internet data transfer. So we have our team. Have developed the two types of the libraries. One is DTF, and the other one is GTT. And today, I will focus on that's DTF. That's makes them coupling. And our DTF purpose is we want to get rid of the file I/O. I mean, file I/O accessing the storage disk in order to speed up the execution. And what I don't want to is we don't like to ask the application developers to change the I/O API. And in the DTF, we assume the applications use Peanut CDF file I/O library. That's a parallel file I/O library developed at Argonne National Laboratory, and that's the read and write the NetCDF the file format. And so how the DTF works? So it's actually intercept Peanut CDF the API calls, and then send the data directly without the accessing file I/O. So this is very, it's a straightforward idea. Okay, this slide shows an overview of DTF. And the application developers do not need to change, modify their file I/O access, the APIs, but a few the APIs must be included into the the applications, and actually just the three APIs added. So the first one is the initialization for the DTF, and so DTF needs to know when the data is actually transferred. So this DTF, the transfer is a hint to transfer the data. So you have to write this the code, and in the last of the program execution, you have to write that this DTF finalize the API. So that's it. That's all. And to at the runtime, so DTF runtime library needs to know what kind of the applications are actually using our DTF, and also what kind of the files or the transfer. So such kind of information must be described in the configuration file. Okay. So that's all. And then your application transparently uses our DTF, and to get the higher, the lower latency of the execution for data transfer. And so we as a first when the project started, so we assumed two applications, so scale and the LTKF are independently launched by npm exec command, and then the npm jobs are connected via npm connect the feature. That's the one of the npm the library features, and so up to 60 ensembles, and that's the 44K nodes used. So it's okay. But so we observed more than 60 ensembles. So in case of 80 ensembles, then it couldn't finish its timeout and expire the machine resource time. And so that's because we think this npm connect the feature implementation is not so optimized. That's because most users do not use this kind of the feature. And so finally, so we designed another way to use the npmd launch feature. That's the one of the MPI standard. So what does this mean is so if you have the two applications, then two applications can be launched at the same time. And but the problem is MPI common word, that the default communicator when your application launched. And so if in this example, two applications are launched, then the npm common word communicator is shared by two applications, and then that means rank number is numbering from this kind of thing. So rank 0 through rank 3 for application 1, and for application 2, not starting the 0, but from 4 to 6. But usually, your application assumes each application has its own communicator. That means the rank number starts from the 0. But also, in case of this execution, it's not. And so we have my colleague implemented the runtime library to separate MPI common word into the MP application. So so instead of this kind of rank the allocation, but using this library, then this kind of rank allocation can be done in that runtime library. And so then the scalability gave the program the runs on using this kind of the command. Okay. Oops. And then, then this is the result. And we run up to 100 ensembles, and here is the result using a K computer. And then the DTF consumes only the shorter than 1 second. Okay? And most execution time is for the scale and LTK. And so in this size, the data movement per iteration per ensemble is this, okay, more than 1 gigabyte from the scale to LTK, and from LTK to scale, about 1 gigabyte data transfer. And in case of 60 the ensemble, that means 165 gigabyte data transfer is required for each iteration. Okay. So this is a summary. And so DTF is not just for coupling scale and the LTK in the Mioshi Crest project, but also we think applicable to the other application using, but the application must use the CDF file library. So, this is the open source. And so if you are interested, so please look at those web pages. Okay, thank you. That's all.